All right, everyone, we're just going to get started with the panel discussion now. Thank you very much for joining us. We're here today to talk about how the definition of clean energy use is changing and what it means for industry and climate. So commercial and industrial corporate energy procurement has played a really essential role in scaling the renewable energy industry from its infancy. PPAs, power purchase agreements, have been a really core revenue stream for solar and wind assets. And in 2023, BNEF estimates that about 10% of all power capacity, so including fossil fuels, had some kind of offtake agreement through a PPA. And the reason for this is a lot of big companies have committed to 100% renewable energy. You see this in marketing a lot, and the RE100, et cetera. But the way these systems have worked is that a company is just buying the amount in megawatt hours it's consumed and then buying that equivalent amount of renewable energy. But oftentimes it's not in the same region as the energy is being consumed. It's not in the same hours as when they're using the energy. And so these energy consumers are pulling from dirty grids, and in reality they do still have emissions. So what we're here to talk about today is the next frontier of clean energy procurement, and that is 24/7 carbon-free energy procurement. You're procuring a megawatt hour of electricity or kilowatt hour of electricity in the hour that you're consuming it and in the region in which you're consuming it. It's a much higher bar to clear, but it's going to have much greater sustainability benefits. So today, I'm joined by my panelists, Devin Sweezy, Senior Manager for Global Energy and Climate at Google, Jose Manuel Perez Rodriguez, Hydrogen Regulation and Government Affairs at EDP Renewables, Eleonore Lazat, Commercial Director at Granular Energy, and Killian Daly, Executive Director at EnergyTag. So thank you very much, everyone, for joining us. First up, why don't each of you explain who you are and what your company does? I'm particularly excited to hear about Google and what Google does.
Yeah, well, thank you, Mark, and nice to see everybody. Thank you to BNEF for hosting this session. I'm really interested in the discussion. So my name is Devin Sweezy. I lead clean energy advocacy at Google, so that's thinking about how Google, as a large energy consumer, can be catalytic in terms of what we're doing to drive decarbonization more broadly. And that's the focus of my role and part of what I'll be talking about today. And Google is a technology company, for those that don't know.
Okay, so my turn. I am Jose Manuel Perez. I lead the Regulation and Government Affairs team at the Hydrogen Business Unit at EDP. EDP is a renewable developer. Well, in the past, we were a classic utility, and we have still dirty assets running, but we have a strong commitment for being completely coal and gas-free by 2030. And hydrogen comes here like a piece to complement our portfolio of renewable development in the future. So I will talk about a bit of it later.
Eleonore?
My intro is going to be the opposite to yours, where I'll spend all the time explaining the company and much less on what I do. I'm from Granular Energy. We're a software company, and we provide solutions to energy suppliers to help them manage their green energy. And what that means is we help them build new products, new tariffs, to help them report their green electricity and their green supply to their customers. So that is, on the back of the existing systems, but also pushing more and more for this transparency, this traceability, and 24/7. So we help them build these tariffs and implement them.
Yeah, so I'm Killian Daly from EnergyTag. So that's a non-profit organization focused on standardizing hourly matching and more granular electricity accounting. And we also work quite a bit on policy and advocacy. Standards like the Greenhouse Gas Protocol are changing. They set the rules of the game for how companies count their emissions. We worked a lot with many of the people on the panel here on hydrogen regulations, both in Europe and the United States, where much more rigorous carbon accounting is going to be required to say that you're consuming clean electricity. So yeah, happy to bring some perspective there today. My background is as an energy buyer, so I used to head up energy strategy at Air Liquide's global procurement for electricity and natural gas. I also know quite a bit about power and gas markets.
And so just to clarify, because I was a bit confused when I started moderating this panel, EnergyTag is setting the standards, and then Granular is helping create these operational systems that apply the standards to tariffs for customers. Okay, cool. So yeah, let's get started. Like the benefits of 24/7 energy procurement. Like, this is by no means an easy thing to do. So Killian, what's the point of this whole effort to do 24/7 energy matching?
Yeah, sure. Well, I think it's to align actually what the system needs with how people procuring electricity are actually doing. So, again, going back to my previous job, you have a job doing power procurement where essentially you're kind of hourly matching and on the same grid all of the time when you're procuring actual physical electricity. Then you move on to your carbon accounting or your green electricity targets, and it's a totally different world. It feels like buying offsets. You don't have to think about any of the constraints of the grid. You can be 100% renewable powered in Spain from Norwegian certificates. It makes absolutely no sense, basically, for anyone who understands power grids. And I think it's to try bring those things together, right? If you have to, each hour of the year on your local grid, procure green electricity or clean electricity, then you have to do that job there. There's no get out of jail free card, I suppose, so there's no easy way out from buying a certificate from a time and place very far away from where you actually need to deal with the problem. And there's quite a lot of research out there now that's showing that this brings a lot of system benefits. So if a company is going to do 24/7 clean PPA, for example, they need to procure lots of local renewables, wind and sun. They need to be flexible with their demand, and they need to also invest in flexible supply-side technologies like storage or even long-duration energy storage. So it kind of sends a much more effective signal for grid decarbonization than the system we have today. And I think another point which is quite important is it's just more transparent. It's kind of less likely to get accusations of greenwashing or something like this because it's understandable, it's kind of explainable to people.
Yeah, when I started looking into this a couple of years ago, I kind of assumed this was how energy matching worked, and then it turned out it didn't really. So Devin, talk to us a little bit more about the benefits from a corporate perspective. Like when you go report to your managers at Google and say, here, we want to do this complex thing that's going to cost us some money, what's the benefits to you?
Yeah, so maybe just to start with a little bit of a brief kind of history of Google's journey to where we are at this point. So we were one of the first companies back in 2010 to sign a power purchase agreement for renewable energy and really trying to help scale that model, which we've seen, you mentioned in your introductory remarks, Mark, has really taken off and is helping to deploy a lot of new wind and solar capacity on grids across the world. And in 2017, we had purchased so much renewable energy under these PPA contracts that we did what you were describing earlier, which is we matched our annual demand on a global basis. So we bought as many megawatt hours from the renewable energy contracts that we had to match our consumption. And today we have over 10 gigawatts of renewable energy projects under contract across the world. But we realized at the time that was a really important milestone to meet, that kind of global annual matching 100% renewable. But it wasn't the same thing as fully decarbonizing our electricity consumption because there were places where we had more procurement, places where we had less. There were certainly times of the day where we were short or long, and we were still reliant on fossil fuels to power much of our operations. And so we set this goal in 2020 to operate on 24/7 carbon-free energy, which, as you said, means time matching and on the same sort of grid, balancing authority where we have consumption, and meeting that goal by 2030. And every year we report our progress. And last year, in 2022, we were 64% on a global average basis, hourly matched. That also obscures a lot of variation right across geographies. Because we're a global company, we operate in a lot of different places. So there are some places where we're above 90%, for instance, matched on an hourly basis in Europe. And so that's kind of where we've kind of come to and where we're headed. And I think there's three main reasons and benefits that we see in the approach in terms of why we did this. Okay, so one is impact, and Killian was mentioning this a bit in his remarks, but there's been a lot of research, especially over the last few years, on from a grid system level, what is the potential impact if more companies start to structure their clean electricity procurement in the direction of local and hourly matching? So organizations like Princeton University, Technical University of Berlin here in Germany, and the International Energy Agency, all of them have looked at this question and they've come to a few core conclusions. One of which is that it will accelerate the decarbonization of the broader electricity system because it encourages companies to build portfolios of clean energy technologies. So instead of just signing a solar-only PPA far from where they're consuming, pairing solar with wind, with battery storage, thinking about firm clean electricity technologies which can help decarbonize the grid faster. So impact is certainly a big one that we think about. The second one is how do we manage our business going forward? So Google is a company that spends billions of dollars a year on electricity, and the growth in that cost and the trajectory of that cost is a really important input into how we plan our business. And increasing the amount of hourly matching with clean electricity contracts that we're purchasing where we're consuming is a way to help minimize the risk of volatile wholesale power prices that we would otherwise be exposed to in the times when we're not matched and we're going to the market for that power. So there's a really important business element that we see in terms of planning our business. And then the third one I'll mention briefly is around this concept of clean capacity, right? So when we go out and we sign a solar project, that's helping to produce energy on the system, but it's not necessarily providing capacity value that enables us to grow long-term vis-a-vis these portfolios that we're helping to build to achieve 24/7. So we're also thinking about how can we be building portfolios that unlocks clean capacity to support our future growth and ensure that we're growing in the cleanest way possible.
Okay, great. So the tech players generally have been huge in the PPA space, so Amazon, Microsoft as well. But I'm actually keen to hear from you, Eleonore, because you talk to everyone who wants to implement these kind of tariffs. Who else do you talk to outside of the tech sector?
So we work more directly with energy suppliers, actually. Your retailers, maybe a few of you in the room, I don't know, the NGs, EDFs, Unipers of this world, because they're interested in deploying it for all of their customers. They're starting to get demand from the tech sector, but also we've seen quite a bit of real estate start asking for this because there are some standards on clean buildings, green buildings, etc. And I think what's really interesting is to see that these suppliers are saying, well, if we develop this, we could provide it to all of our customers potentially, probably at a price, so not for everybody. But and I think there's three key drivers for them. One, this customer demand for it. Two, some sort of competitive edge, right? If you want to be greener, if you want to launch new products, if you want to be ahead of your competitors. And then finally, be ahead of upcoming regulation, be ready for what's coming. I think we're going to touch upon it a little bit more, but for hydrogen, if you want to be able to develop and provide green hydrogen, well, you're the expert. I'll leave it to you. You have to do hourly matching. So that's what we're seeing. But in terms of which buyers are ready for this, what we're seeing is some leaders like Google who are saying, hey, we're committing to 100% 24/7 CFE by a certain date. A lot of the followers are saying, look, we're not going to commit to a percentage, but we're going to get that transparency because we understand the difference between annual and hourly matching. And it's important as a baseline to say, okay, what is my hourly matching? And that we're seeing lots more companies start asking their suppliers or looking into solutions to get that information.
Okay, so the energy suppliers need to be ready if their customers ask for it. Okay. I remember you mentioned you were working with an energy supplier that was like consumer focused. Is there like a big end consumer like in their house who wants this? Or is this just a niche thing for now?
It's it's the early movers, it's a voluntary market. It's still mostly for like B2B suppliers who have big businesses, who are signing PPAs, who are thinking about this. We are working with a smaller supplier that's doing it on a residential level. Because it's their brand, because it's their mission, because they've been doing years and years of work on trying to say, hey, we need to shake this system up.
Cool. Okay, so Jose, EDP, it's known as an energy generator. You're here kind of as an energy consumer. Can you walk us through the decision at EDP to invest in the capability to procure this 24/7 clean power?
Yeah, exactly. This time EDP has a new role. The hydrogen unit sits in the other side of the table. We are dealing and negotiating with our energy trading units to get the PPAs, the electricity PPAs that we need to make the investment decisions on our projects. We are here. We feel like a startup inside EDP that is a very big company, and we are a very small team so far. And the motivation for creating this team inside EDP, there were several, but I will say that perhaps there are two main motivations. One is that with renewable hydrogen, we will enter sectors of the economy that were close to electrification. Electrification is still our main driver. Is whatever demand, whatever fossil fuel that can be electrified should be electrified first because it's the most efficient way. But for those uses, particularly, for instance, for feedstock that is not possible to electrify, renewable hydrogen appears as the best alternative or the best choice. So we are there to enter these sectors of the economy, the fertilizers, the steel, that perhaps we were significant in terms of electricity consumption, but not in the part of the gas consumption. And the other motivation is that, as I said before, we have still 6 coal power plants in different stages of closing down. Some of them are still in operation. And when we discuss our plans to future transformation of the company, and we saw the alternatives for these sites, we decided that we should be committed with the sites that we traditionally have been there for 40 years producing energy from coal, and we couldn't just close down and leave. We should look for alternatives for these sites. We analyzed several possibilities, and hydrogen appears like perhaps the most logical solution, because there are a lot of things in common in terms of electricity infrastructure, civil infrastructures, water, even potential of takers. Our coal power plants are next to ports, so allowing for future exports. So it actually makes a lot of sense to develop hubs in these locations. And so we started to develop our projects in these locations, because we also have the certainty that although the off-taking is not really committed and not prepared yet for that, and although hydrogen is not competitive yet compared to the fossil fuel alternative, we know that we can trust in our sites and start developing there and putting some money and DevEx in these projects, because we know that somewhere in the future, in some moment, somebody is going to buy our product. We don't know exactly when. In the meantime, we are developing at the same time in the same location the small size project and also the very big one. So we are ready to develop the projects and going ahead with the investment decisions whenever the market is ready for that. So, we see this as a logical path also for decarbonization. Also, is our goal that we are following as a company. And of course, hydrogen, and this links to the 24/7, to make sure that the hydrogen decarbonizes. There is no other choice that making sure that the PPAs are 24/7. Otherwise, it will mean that you are using directly or indirectly electricity that comes from other sources. And if hydrogen, given its low efficiency in the process of making hydrogen, if you use hydrogen from these other fossil fuel sources, coming from electricity from coal or from natural gas, directly or indirectly, the emissions of hydrogen will rise a lot. That will be a worse choice than keeping on making hydrogen in the old-fashioned way. For legal certainty of the investment in our projects, we bet that 24/7 is the solution. There is no other choice. Otherwise, somebody in the future will notice that there is a lot of hydrogen produced with a lot of emissions associated, and may cut the subsidies or may change the rules, and we cannot allow for that. So this is our choice. Things should be properly regulated from the very beginning.
Okay, so it's basically to be ready for the regulation when it comes.
Yes.
Killian, could you actually maybe just give us a broader view of what the most important policies are? There's obviously the regulation about in Europe what you need to do for hydrogen production. Is it similar in the US? Are there other policies that are important?
Yeah, absolutely. So I can touch on a few things. I think it's kind of interesting because we've seen some of these mechanisms probably originate in the voluntary space, like targets like Google's and Microsoft's. But actually, there's a very fundamental question, I think, that a lot of regulators are grappling with and have grappled with. It's what is clean electricity usage? How do we produce a product using clean electricity? What sort of guardrails do we need around that? So the European Union had long and relatively heated debates, I think, about what rules should be put in place for RFNBO or renewable hydrogen. And where they landed was basically with some phase-ins requiring this hourly matching approach by 2030. In the United States, there's a very significant tax credit for clean hydrogen, the 45V section of the Inflation Reduction Act. And to get your $3 per kilo, what the Treasury is proposing in their draft rules, they're not yet finalized, it's likely year end where they'll be finalized. They're proposing basically the same thing as we are here in Europe, that you need to have this strict hourly matching approach in order to claim the electricity usage as being clean. So that's the start, I think, of a kind of a transatlantic agreement, let's say, or alignment on what's clean electricity use. And I think it's only the beginning, to be honest, because that question you must then also ask it for other electrification of heavy industry, for example. I think it will come in for sure into the CBAM discussion ongoing, so the Carbon Border Adjustment Mechanism, where Europe is going to have a tax at its borders for imports of carbon-intensive products. Something like aluminium, its emissions are dominated by electricity emissions, so that accounting must be done correctly. PPAs will be allowed in CBAM, and the Commission is currently putting together the rules for exactly what that is going to look like. So I think that's something, a big one to look out for as well. Next year, the Commission will come out with its more defined rules on that. And to be honest, that will start to set a kind of a de facto global standard, I would say, for what is clean electricity consumption. There's also more localized topics. So Ireland, where we're from, has obviously a lot of data centers. So 20% of consumption is already from data centers. And the government is going to require those data centers to do hourly matched accounting, well before 2030. And is already actually asking some data centers before they start to build, how are you going to supply this data center with clean electricity on an hourly basis? And that's a planning condition. So Ireland doesn't have a lot of interconnection, has a lot of load growth, and so is looking towards these mechanisms to make sure we're not building a lot more gas capacity to supply this new load. I think it's going to pop up more and more places. It's already emerged in hydrogen, I think, quite strongly, but it's going to happen across other sectors as well, where this key question of what is clean electricity use needs to be answered.
So actually, Devin, I'm going to ask you about that. I'm very familiar with the story in Ireland, but I have seen some news stories that a utility in Ohio, for example, is saying it's not any more data centers because it's considered like non-essential relative to serving customers and manufacturing facilities. So are there other big markets where you think this type of load growth might affect the development of 24/7 clean power procurement?
Yeah, well, I think in general, this multi-decade era of sort of flat load growth that we've seen in the US and in Europe in many ways is over, right? And we're entering this completely new paradigm, and that's driven by, as you say, sort of manufacturing load, electrification of buildings, industry, transport, hydrogen. Electrolytic hydrogen is going to be a big driver of that load, and also the digitization of the economy and the growth of data centers. And I think, when we think about the sort of scrutiny and the growth of our demand going forward, this is one of the key reasons why we see such importance in trying to drive towards 24/7 solutions, because we can no longer be, and we haven't been for some time, but it's not possible to be sort of a passive consumer as we grow. We need to be an active participant in the clean energy transition in a way that aligns with the broader objectives of governments and society to decarbonize. And so that's a big reason why the 24/7 approach sort of enables that systems level thinking in terms of how we think about the innovations that we're creating to enable broader grid decarbonization. And there's a couple I can mention just really briefly. One is around demand flexibility. So data centers aren't typically seen as very sort of flexible energy consumers, but actually there's a lot of work that we've been doing over the last few years to identify ways to make some of our demand more flexible by shifting computing jobs in time and in space, delaying a computing job that may not need to be run immediately and shifting it to a time when the grid is cleaner, or turning down our demand a certain percentage to support grid constraints and relieve constraints on the grid. So how can we be more flexible and be more of an active participant in that way? And then the other one that I think is maybe more directly related to the question around utilities and load growth is we're working very closely with utilities and grid operators here in Europe, but utilities in the US, on new regulatory structures that enable this portfolio of clean energy technologies to be built so that we don't need to build other traditional generation technologies to supply that load. And so there's something that we call, sorry.
Were you involved with that Duke announcement?
Exactly, thank you, yeah. So it's called what we call a clean transition tariff, or CTT. So folks might be familiar with green tariffs, which is essentially, when you build a solar project for a customer and you kind of sleeve it through the utility to meet the customer's load. But typically that's one generation technology like a solar only. So how do we turn that into a multi-technology tariff that meets a customer's demand on more of an hour-by-hour basis and provides the clean capacity needed for customers to support customer growth? And indeed, a couple of weeks ago, we were excited about an announcement that we and a number of peers signed an agreement with Duke Energy in the Carolinas to create this clean transition tariff model to ensure that clean capacity is delivered to the system to enable future energy growth.
Okay, cool. So we've heard this sounds very essential. There's loads of regulatory and demand reasons why we need to develop this, but it's not simple. So let's dive into why it's hard and what we can do about that. So Devin, I'll go back to you. What about cost premiums? How much more expensive is it to match hourly compared to annually?
Yeah, so our experience is that we can, and we've talked to many energy suppliers and renewable developers as we approach this goal. We can typically get to fairly high shares of hourly matching, things around 85 to 90% hourly matching at a premium that is comparable to annual matching, to signing just a 100% sort of volumetric PPA today. And the research is showing that already getting to 75, 80, 85% hourly matching can have a bigger impact in terms of decarbonization than 100% annual matching. So certainly at those high levels, we see a reasonable premium compared to annual matching. When you go from sort of 90 to 95% and certainly up to 100%, it gets more expensive. And part of the reason, certainly for sort of more of a baseload consumer like Google, is that you need to sort of overbuild renewable capacity relative to your demand in order to cover those hours. What we have found is that premium can be significantly reduced by using technologies that include wind, solar, and storage, but thinking about other technologies that can also be part of the mix, including firm dispatchable clean electricity technologies or long-duration energy storage technologies. And we may come back to that, but that's how we've been thinking about it on a portfolio basis in order to reduce that premium to get all the way to 100%.
Yeah, that idea of is it just wind and solar and batteries and you really build over capacity, or do you have some hydro or geothermal is pretty interesting. So Jose, interested in your experience, regionally, it's obviously easier to do 100% matching in Sweden or Norway where there's a lot of hydro. What's your thoughts on resource availability in regions where you might build some hydrogen plants because of this?
Okay, in the case of EDP, we are conditioned by the regions in we are actually working already. So we prefer to develop our hydrogen projects in the places that we know better, because permitting is complicated. To start developing the projects, you need some land. Also, you need to deal with the policymakers, and that's the reason we decided to focus our activity in the markets that we are incumbent, like Iberia, Brazil, and the US. So these are the markets that we chose to work on. And particularly in Iberia, we have 5 coal power plants sites, 1 in Portugal and 4 in Spain. And in Iberia, you find also that you have a good solar resource, you have also a good wind resource. We have 5 gigas of hydro installed in Iberia because this comes as an inheritance from our past activities as classic utility. So all of these combined together, perhaps it's not the best place in terms of hydro, perhaps it's not the best place in terms of wind, but we are conditioned by developing our projects in the places that we know better. I perhaps should say, I was forgetting what I was about to say. Iberia, it's also a place that has very low interconnection in terms of electricity. So hydrogen and its derivatives appear as a solution to export energy, future solution for exporting energy from Iberia. So that also makes an interesting place to develop hydrogen projects, and also particularly those ones that are next to ports. We have particularly 3 locations, 1 in Portugal and 2 in Spain, that are very close to ports, and we are already in conversations with the ports for making possible in the future for exporting the hydrogen and its derivatives, overcoming the inconvenience of being the Iberian Peninsula an isolated region in terms of energy interconnections.
Okay. Killian, interested in your thoughts on, you talked to lots of corporates who are interested in this. What do people say in the boardroom about like why this can't be done or why it's hard for them?
Just a thing on costs, first of all, and it's kind of linked, I suppose. One thing that definitely comes out through a lot of this is I think the value of flexibility of demand is going to be, we kind of know that already from where electricity markets are going. That's going to be critical. Because when we hear 24/7, yeah, I think it's a good name to get the concept into people's heads, but it doesn't just mean that you're a baseload consumer and then you need to find a supply portfolio that matches perfectly your baseload demand. It can also mean be flexible 10% of the time and avoid the really expensive hours. So that there's many ways of getting there, and I think demand flexibility will have a key role.
I actually just saw one of the really big aluminum smelters in New Zealand has signed this massive demand response contract.
Yep.
Now.
Yeah. And so I used to work in heavy industry, and I think sometimes there has been, let's not touch the process because it's worked for 100 years. But I think there are, of course, not every industrial site can be completely flexible. I'm not naive, but there are places we can squeeze out 5-10% that could be very valuable. The other thing is about, when we talk about the cost question, it kind of irks me a little bit because you don't really know how much something has cost with long-term hedges until after the fact, right? Like you don't know what the counterfactual is. So if you're just leaving yourself completely exposed to spot markets, that's extremely risky. Or to be honest, if you're signing a solar PPA that's delivering 20% of your load and leaving yourself exposed for all those hours when it's not sunny, with cannibalization of renewables today and where electricity markets are going in the expensive hours, that's very risky. So maybe paying a price premium for a PPA that is much more, let's say 70% match to a base load. Okay, the price on the front page is going to be a bit more day one, but it could be way more valuable. And there is modeling done on that by Pexapark and Your Electric showing that these 24/7 PPAs, especially during the energy price crisis, they could have saved you tens of millions of dollars if you're just a 10-20 megawatt consumer. So I think thinking about what's the value here in the long run, given where markets are going, I think that's really important. I think when people, the initial reaction people have when we talk about, let's say, the board level, or when I talk to, like, let's say some CEOs of hydrogen companies, I think there's a bit of a knee-jerk reaction saying we need to run these electrolyzers all the time and therefore this is impossible, the costs are going to be too much. So, and again, I try to, I always touch on this hedging point. Are you really just going to build your electrolyzer and not hedge it properly? And I think the flexibility of electrolyzers is going to be absolutely critical. I think the last thing we should be doing is building a load of base load electrolyzers. So yeah, I think they're kind of two key points, is to kind of hopefully make them look at the question in a different way and make sure that they're understanding that this has value. And I think the final one, I touched on it earlier, it's just around, like, and you touched on it as well, Emmanuel, is like just transparency. I think people working at least in technical firms, they know that 100% renewable based on solar, it doesn't make sense. Like, of course it doesn't make sense. So if you're going to kind of build a 10, 20-year strategy on that has an inherent risk just built in, that you can brush it under the rug maybe for a few years, but it's going to become a problem. So better to future-proof yourself from day one. Yeah.
Cool. And then Eleonore, on the operational side, like when you're actually implementing these for energy suppliers, what's the challenges that you often encounter?
I think there's a few building blocks that are coming together, and I think the first part of what we're trying to achieve, we've got the technology, we've got the data, we've got the operation set up, right? To give you an image of your hourly matching is pretty simple. You take metering data from the generation sites you've contracted with, from your consumption site, and you put them against each other. So that is a fairly simple process. Metering data exists, grids have it, cool.
Does that exist, just from a market's perspective, are you mostly active in Europe? Is this available everywhere?
We're active in 10 different countries, I think, right now. Okay. With varying levels of grid data. Okay. However, it's never been the main challenge. Actually, we've got In the UK, half hourly. In Germany, quarter hourly metering data. Like, that data exists. So that, I wouldn't say, is the main challenge. I think the challenge and what's missing and what we still need to build is thinking about, okay, well, now I know my hourly matching. That's the first step. I've got this transparency. How do I work on it? How do I really try increase it or improve it? And a big piece of the answer will be hourly certificates. So having a certificate, an official commodity complementing or replacing the existing, renewable energy certificates or guarantees of origin, to be able to work on that. And the really important piece of that is that the certificate will give that razor-sharp price signal to assets at the right time, right? If you need power in the night, and there's no wind, no sun, it'll be more expensive. And so that certificate piece still needs to be built to some extent. Some countries are more advanced than others, but yeah, registries that are regulated most of the time are in that process, yet yeah, we'd love to see that speed up a little.
Okay, cool. I have a few more questions. Gonna open it to the room in about 5 minutes, so please start preparing your questions if you have any. But onto like the logistics of actually arranging this. I can imagine this is so complicated. Like, you have this whole portfolio of like solar and wind. So is this like a really coordinated effort? Can you talk us through maybe a little bit of the logistics, Devin?
Yeah, absolutely, and it's not unlike what Eleonore was sort of describing in terms of how we started our journey. So I think the first step is to understand where you're at, right? In order to get to set a goal and whatever percentage you're trying to reach, you need to sort of baseline your hourly matching and understand the sort of consumption data on an hourly basis. So we've done that over the past few years for all of our data center sites and office campuses across the world, and understanding the sort of hourly supply of the contracts that we already had under contract, right, and how that matched up. So that's the first piece, is to sort of understand the kind of baseline your data. And then second is thinking around procurement constructs. And I think there's a lot of different options that companies can use to move towards higher levels of hourly matching, one of which is these granular certificates, which we're also big supporters of and have advanced in a number of places for our own portfolio that Eleonore was mentioning.
I say, like, you'd prefer go to a market that has these certificates rather than like doing a lot of this work internally.
Well, so yeah, I mean, ideally in the future there will be these sort of certificates offered, off the shelf. At the moment, in a lot of places, what we're doing is we're using hourly data from the production and the consumption and matching that to an existing certificate in the system in a way that ensures that there's no double counting. So there's actually a way to advance on hourly matching in the absence of the sort of hourly certificates being issued themselves. And then EnergyTag, Killian can talk a lot about this because it's part of the EnergyTag standard. So the certificates are part of it. The one other thing I'll mention is we've worked a lot with energy suppliers to create new supply structures that enable a higher degree of hourly matching. So a couple of examples in the US with AES, in Germany here actually with ENGIE a couple of years ago, something we call a carbon-free energy manager model, where we work with the energy supplier that assembles a portfolio of clean energy technologies, maybe wind plus solar plus battery storage, on our behalf, and then guarantees a certain amount of hourly matching in the contract. And there are sort of bonuses and penalties around that number. And that number is going to be different for every consumer, but these structures are proliferating. And I think this is one of the ways that we're going to get more companies to engage more in this discussion, is to create these structures with suppliers that know how to do this.
Okay, and Jose, I'm interested, how has your clean power procurement team changed? Does this become a core part of their job?
Yeah, it will be interesting to know also. I mean, we are dealing with many interfaces at the same time, and it's even more complicated from our perspective because we are not the final consumers, the final users of the energy. It's another off-taker or several off-takers. So the first thing that you have to know very well is the process, the industrial process of your off-takers, the ones that are going to use the hydrogen that you produce. So we work very closely with them, even assessing, evaluating their processes, trying to analyze if there is any more flexibility that we can get. Because when you work together with them, you realize that what they really want is a base load. We have an industrial process that has to work 24/7 also, and we have to use 100% of our capacity, and you have to provide me with the hydrogen that I need every time. So it's very difficult to manage flexibility from them. But I mean, there are some possibilities. Also, if you work at the same time, like us, with several off-takers at the same time, because our projects are hub projects destined for not a single off-taker, but for several. So, well, I mean, we can find a slight flexibility from them. The second thing that you have to know is your technology. So electrolyzers, as was already mentioned, are flexible, but they cannot work very well at low loads. So, I mean, depending on the technology, for instance, PEM technology allows for you to operate at higher base loads, at higher minimum loads, like 40, 50%. But alkaline, it's difficult because you cannot, you have to work even in higher loads. So you have to find a good combination of several technologies, perhaps in your site, designed according to the needs of your off-taker. Then you have to know the profile of your renewables. And if you work in portfolio in the diversified geographical locations, if you work diversifying also the renewable source, a mix between solar and wind, also you have to find the perfect combination between the two of them, depending on the needs of your off-takers, so you have to match all of that. And also, if you work in a portfolio of several electrolysis in the same region, like us, I mean, we have under development more than one project in Spain, so we are thinking on how to combine the demands simultaneously at the same time of the off-takers for choosing, optimizing every time, every hour, how to allocate the renewable energy source into the different electrolysis plants. And in the end, you realize that it's impossible, as was already mentioned, to comply 100%. So you have to see where your limits are. So you have to admit some non-compliance and to play with the emissions, the indirect emissions that will come if you use electricity that does not come from renewable sources. And depending on what rules you have to follow, perhaps the off-taker has some requirements in terms of emissions that will come with the product. Perhaps the funding mechanism that is behind the economics of your project has its own rules that you have to follow as well. For instance, the Hydrogen Bank has strict rules regarding the emissions that will come with the product. And also the general rules of the country. I mean, the Renewable Energy Directive that has targets for hydrogen and the renewable hydrogen that has to be supplied to industry or for transport. You have to follow those rules as well. So mixing everything together, I guess that our energy procurement teams and energy management teams in the future are going to go crazy, having all of these things at the same time together.
Like a lot.
That's where solutions like us come in.
Exactly.
We do the work for you.
Okay, one more, in one sentence or less before we open the questions to the audience. What would you do, like wave your magic wand to push this industry forward? Killian, I'll start with you.
Well, I think you need to change the standards and the rules of the game. Because obviously, if you could, my job and every energy procurement person's job is to get to green at least cost. So you shouldn't expect them to go and necessarily do a lot of extra things voluntarily. So I think you need to change the standards for what green really means.
Impressive use of conjunctions there. Eleonore.
I'll add on top of it, right? So we're going to build up all the needs. I'd say, and I'd actually encourage everyone in the room, to just go and ask your supplier, what are you selling me? Am I on certificates or PPA? What does it really look like? What's my hourly matching and what can I get? Because actually, that demand will start triggering everything in motion and lead to more development of it.
Jose?
Well, for me, the key of the success of all of this is the legal certainty. I mean, we have, for instance, for hydrogen, the Delegated Act in Europe. Hopefully, we will have similar rules in the US. But all of us, all the industry, the transport, all the sectors, we have to know that these rules are here to stay. So we shouldn't have the feeling that well, if we don't comply with this, if it is impossible, then we will have more relaxed rules. No. We need a clear roadmap for this. Otherwise, nobody will take this seriously, and we have environmental targets to comply.
Devin?
I would say changing the paradigm for how we think about what electricity decarbonization progress means from sort of the current approach of 100% annual matching, where often that's met in ways that aren't actually having as much of a significant impact on the grid, towards really just recognizing where we're at and then making progress and being celebrated for going from 50 to 60 to 70%. I mean, you don't have to get to 100% immediately, it's a journey. And so we kind of need to reframe how we think about what success looks like, and so that companies are willing to be transparent and then do the work to move through that.
Okay, cool. I don't know if we have a microphone in the room. If we do, do we want to pass that up to the front? We have a question here. Just here.
Thank you. One question that popped up right at the beginning. How do you see the role of the revision of the greenhouse gas protocol? I mean, given the fact that the European Union has at least 4 different approaches on this topic in place. One for CSRD, which is referencing the GHG protocol, one for automotive batteries, which is actually prescribing location average, one for CBAM, and another one for hydrogen. So obviously, a globally accepted standard would be highly advisable. The question is, what do you believe GHGP will succeed? And will it do so
Killian.
before everybody has designed their industrial policy-led favorite method for their favorite product?
I think it's spot on question. So the greenhouse gas protocol was meant to publish the end of next year. Now it's looking like the end of 2026. So there's going to be a lot of decisions made, especially here in Europe and also in US with 45V before that. Obviously I'm biased, right? But I would hope that they would go in the direction of saying, we need more granular hourly matched accounting. And I think if they do something completely radically different, some sort of, much, much broader, looser approach, I think you may see a kind of a fracture. Because what the European Union has done on hydrogen, for example, or the US, I think it does kind of set a precedent for where the greenhouse gas protocol needs to go. And also they'll look at some of the evidence, and there's not really a lot of evidence for alternative approaches, at least to date. But yeah, it's still quite early days. It's hard to really predict where they will go. I think who gets selected on a lot of those governance committees upcoming in the next couple of months will tell us probably a lot of where they would like things to go. But yeah, it's kind of a watch this space, I suppose.
I have another question.
I work with Nucleo. We're developing small modular reactors. So we've been talking about wind, solar, and storage. But one of the things that as a business we're actively looking at is co-locating with energy-intensive users and industrial clusters. So the question is, to what extent would having low-carbon baseload generation on site, potentially private wired, resolve some of these issues? And are you looking at emerging technologies like that? Because
I think
our commercial, we're looking at commercial operation by 2033, which is next week in terms of energy infrastructure development. So it's not today, but it's soon.
I can start, and then I know some other folks are working on this too. So certainly, yes. So last year we published a paper about what we call advanced clean electricity technologies, which I sort of alluded to earlier. It's sort of beyond wind, solar, and batteries, which we think are going to be core to decarbonization in most of the grids where we operate. How can we support these emerging technologies that provide firm and dispatchable clean power, including advanced nuclear, including next generation geothermal, clean hydrogen, long duration energy storage. And actually just a few months ago in the United States, we announced a partnership with Microsoft and Nucor to aggregate our electricity demand to support exactly those technologies, to help scale them up, help break down some of the barriers to commercialization, reduce some of the risks so that we can have those technologies be scaled and brought down in cost for everybody when they need to be. That's something that we're also hoping to do elsewhere. And it's one of the things that we find and that we report in that paper is that also including these technologies, at least some, and even a small fraction, reduces the cost of this 24/7 clean power portfolio, 24/7 matching, pretty significantly compared to a scenario where you're only using wind, solar, and storage. So we definitely see business value in supporting these technologies, but we also see a role for large energy consumers like Google and others to help bring them down the cost curve, and that's something we're really focused on at the moment.
Did anyone else have a comment for the panel, or we can go for another question?
Well, yeah, just very quickly, I think if you look at any of the modeling, obviously if you do have an affordable, clean, dispatchable source of electricity like new nuclear, then yeah, of course, that's going to be, make things a lot easier and have a lot of things like hedging value going forward. So yeah, absolutely has a key role to play if it can be done in time and at cost.
Any other questions over here?
Slightly off topic. At COP this year, everyone talked about tripling clean energy generation and doubling efficiency. How does efficiency fit into this discussion? Because we're talking here a lot about simply, hey, make more of the power we need, but it seems to be a topic that nobody seems to be covering really. How are we going to get double the energy efficiency in the time frame we're given?
Any comments?
So I can start. Certainly on the operational side, efficiency is a really important thing that we think about all the time in terms of how we design and operate our data centers. So our data centers today are some of the most efficient with respect to sort of power usage effectiveness, which is the amount of electricity that's not used for computing, for things like cooling the data center, operating as efficiently as possible. Obviously, there are a lot of innovations happening around the hardware side as well for more efficient computing, and I think a lot of that's going to continue over time, including through things like artificial intelligence that are coming. I think this is actually also an area where large buyers that are thinking about how they drive decarbonization from a systems perspective can engage with other companies and also communities to drive efficiency forward. And actually in the United States, we've been doing a lot of this with, including a partnership with EDP in the US, where we're working on a community basis to fund energy efficiency retrofits and upgrades, as well as distributed and community solar, in addition to large-scale utility solar in the grids where we're operating, and then buying the credits associated with those to match against our consumption. So I think there's a lot of ways that large buyers can intervene to drive efficiency across the economy, even as they're approaching their broader clean electricity goals in tandem.
Okay, great. I'm afraid that's all we have time for. So thank you everyone for joining us for lunch. The plenary will be starting again soon in 5 minutes, and please join me in giving my panelists a round of applause.